Basic statistics, measures of variance. Measure of variance describes how spread out the data is within the set. For example, a set can be clumped tight, or maybe it could be spread out. There are many types of measures of variations, but we will focus on two: standard deviation and the coefficient of variation. Standard deviation is the most common measure of spread. It is a positive number that describes how the data points are spread out with respect to the mean. Small values of the data set, small values of the standard deviation says that the points are pretty close to the mean. A large standard deviation says that the data points are pretty scattered away from the mean. Computing the standard deviation by hand can be a bit cumbersome, requiring several steps and using a table or chart. First step, the steps are as follows. First, we find the mean. Second, we make a chart with 3 columns, one for each data point, a second for a column for the difference between the data and the mean, and a third for the square of this difference. Third, we fill out the columns on the chart. Fourth, add up the numbers in the third column. And fifth step, we divide this sum by n-1, where n is the number of data points. And finally, take the square root of this number. The formula and notation are given below. We write S to represent standard deviation. An example for finding standard deviation. Let's take the set 1.5, 4, 6.5, 8, 8, 10.5, and 12 cc's. First, let's find the mean. Mean 7.21. Then we make up the columns. Now we add up the last column to get 78.4287. We note that there are 7 values, so we divide by n-1, which is 6 in this case. Then finally we take the square root to get 3.62. So the standard deviation is 3.62. I mentioned that it was quite cumbersome to compute the standard deviation by hand, so it is important to know how to use technology to compute it. Many calculators and statistical programs can compute the standard deviation quickly, but the most common program would be a spreadsheet, such as Excel or Google Docs, using the STDEV formula. There are lots of other statistics that you can compute with these spreadsheets, such as the mean and the median. So here's how you find the standard deviation. You simply type in the data in the column, then on any cell you type in the equal sign, then STDEV, then open parentheses. Then you use your cursor to drag a set of numbers, close the parentheses, and hit enter. Then you have your standard deviation. As a result of the mean and standard deviation, there is a rule that applies to the data that's pretty close to being bell-shaped. The empirical rule states that about 68% of the data is within 1 standard deviation of the mean. 95% of the data is within 2 standard deviations of the mean. And almost all the data, 99.7%, is within 3 standard deviations of the mean. This is the accompanying picture of the empirical rule. A bell-shaped curve such as this is said to be normally distributed. We therefore associate the normal distribution to such a set of data that can apply the empirical rule. There are many phenomena in health science where the empirical rule can be applied. Take, for example, the duration of pregnancy. Suppose the average mean pregnancy is 270 days and the standard deviation is 15 days. What is the range of days that 95% of pregnancies have? Well, by the empirical rule, 95% of the data lies within 2 standard deviations of the mean. So if we take the mean, subtract twice the standard deviation, and we'll get the lower bound. If we take the mean and add twice the standard deviation, we get the upper bound. So given the data, we can say that about 95% of pregnancies are between 240 days and 300 days. Our last topic is the coefficient of variation, or CV or COV. This number is actually a percentage that gives some value to how much variation there is from the mean. Since the calculation involves both the mean and the standard deviation, this allows you to compare different data sets with different means and standard deviations. As an example, if we go back to our data set, our past calculations, we found the mean to be 7.21 and standard deviation is 3.62. So our coefficient of variation is the ratio of the standard deviation to the mean, which is 50.2%. Coefficient of variation is applied in many scenarios where different data sets are found with different means and standard deviations. As an example, we could be collecting cholesterol data from different labs. The CDC would send controlled samples to different labs and check the results. If the sample's coefficients of variations are not within 3%, then the lab may not be processing the cholesterol checks correctly. For example, a sample of cholesterol is checked in the same lab 5 times. Each time it was checked, it came back with a different result as given: 187, 182, 201, 208, and 188 milligrams per deciliter. The first step is to find the mean. And in this case, the mean is 193.2. The next step is to find the standard deviation. For this data, S is 10.8. So given the mean and standard deviation, the coefficient of variance is 5.6. Since this is beyond the CDC standards, the lab may be examined by the CDC for inaccurate cholesterol testing. Some final notes on variation. Standard deviation is a good indicator of variation from the mean for a given sample because it has the same units as the original data set. On the other hand, the coefficient of variation has no dimension and can be used to compare different data sets. Just as some final thoughts, we have here are some examples of when variation is used in health careers. A growth chart is based on a bell curve. This marks a child's growth compared to the national mean and standard deviation. Finally, a cholesterol chart keeps track of a person's cholesterol and has boundaries of 2 standard deviations away from the mean. So as you can see, statistics plays an important part in health science careers.